Hello students, my name is Shashank Shekhar. So let us continue with the exercise of NCERT for solution chapter. So the question says that naloxone, similar to morphine, is used to combat withdrawal symptoms in narcotic user. The dose of naltrexone user is naltrexone generally is 1.5 milligram. Calculate the mass in 1.5 molar solution. So in 1.5 we have to calculate the mass of 1.5 molar solution required for the above dose. So what is being asked here, that the number of moles should be 1.5. Okay, number of moles should not be 1.5, it should be 1.5 into 10 to the power minus 3 divided by molar mass of, say, this C19H12, that would be 19 into 12 plus 21 plus 14 plus 3 into 16. So this is the number of moles that is required. Now it is given that in 1 kg we have 1.5 to 5 into 10 to the power minus 3. So in how many kgs we will have this much. Okay, so I will calculate it. So it will be simply 1.5 into 10 to the power minus 3 into x. Okay, clear? So we do not need to calculate the number of moles, right? So in 1 kg we have 1.5 into 10 to the power minus 3 moles of moles of your naloxone. And how many moles we need? We will need 19 into 12, 21 plus 14 plus 16 into 3. So calculate this value of x, you will get your answer. So they have done the same thing. Okay, that would give us 3.22 gram. Calculate the amount of benzoic acid required for preparing 250 ml of 0.15 m. So how many moles of C6H5COOH are present in 250 ml of 0.15? So that would be 250 into 10 to the power minus 3 multiplied by 0.15. So this much moles of benzoic acid is required. Okay, so that would give us how much? 250 into 0.15 to 25 5 ja. So let us just multiply it. 15 5 ja 75, 15 2 ja 30, 375. Okay, so if we calculate this, 10 to the power minus 5 or 10 to the power minus 4, 3.75 into 10 to the power minus 2. So this is the moles of benzoic acid required. Now if we multiply it with the molar mass, so its molar mass will be 12 into 6 plus 5, 12, 16 into 2 plus 1. So you solve this, you will get your answer. So first we have calculated the number of moles, multiplied it by the molar mass to get your final answer. Next is the depression in freezing point of water observed for the same amount of acetic acid, trichloric acid, and is given in the order. Explain briefly. So which would give the more depression in freezing point? So the one which is less volatile will give more depression. Okay, which is less volatile will give more depression. So we have to see that which is giving more depression in freezing point. Okay, so the one with less volatile will be giving more depression. So out of acetic acid, trichloroacetic acid, trifluoroacetic acid, the trifluoroacetic acid is most having the most dipole moment, so it will be less volatile. Least volatile then will be our trichloroacetic acid and then acetic acid. Therefore the acetic acid will have the least depression in freezing point. Okay, it will have the least depression freezing point, then will trichloroacetic acid and then trifluoroacetic acid. So very simple to solve. We just have to see that which one is having a greater dipole moment. Greater dipole moment means greater interaction between the molecules, so less volatile. Okay, so we know that fluoroacetic acid, trifluoroacetic acid is in this way, and we know that it is very polar due to the presence of this CF3 group. Okay, so that would increase the boiling point, or you can say the volatility of this trifluoroacetic acid. Calculate the depression in freezing point when 10 gram of this is added to 250 gram of this. K is given, Kf is given. So how we will solve it? So first, what we have to do is we have to find the concentration of this acid that is being dissolved in water or that has been broken. For that, K is provided. So if you remember the formula for equilibrium, it is C alpha square by C into 1 minus alpha. C cancel. So it would be C alpha square by C alpha square is equals to K. So this is our K, and C alpha is the concentration of your acetic acid. So let me solve it for you. So we have the formula as CH3 CH2 CH3 CH2 CH Cl COOH. If it is ionized in water, then it will form so this will be the result of partial ionization. So initially we have C alpha, after time t it will be C minus C alpha, it would be C alpha, and this will be C alpha, because one equivalent of this will produce one equivalent of this and one equivalent of this. So since C alpha has been consumed, so C alpha will be produced and C alpha will be produced here also. So if you write K for this, then it would be C alpha into C alpha divided by C minus C alpha. Okay, so if you take out the C common here, this C and C will be cancelled out. That would result in alpha square by 1 minus alpha. Now 1 minus alpha is approximated to alpha. Okay, therefore C alpha square is equals to Ka. Now if you see here, then the concentration of CH3CH2 that is being ionized is C alpha. So if we calculate C alpha, then we will calculate Ka. So what will be the value of C alpha? It will be C alpha will be equals to Ka. So if you multiply C on both sides, so that would give us root Kc. Right, that would give us root K into C. So this will be the concentration of H plus or CH3O minus. Got it? So with this we will be able to calculate the concentration of this thing in water. After that, once we got this, once we are getting this thing, then what we can do, we have to just calculate that 10 gram of this is added. So therefore molality is equals to 10 by, so carbons 1 2 3 4 carbons, so that is 12 into 4 plus hydrogen 3 to 5 6 7 2 oxygen, that is 16 into 2 plus 35.5 into 35.5, yeah, divided by, so we have 250 gram of water, so 250 into 10 to the power minus 3. So this will be our molality. We have molality, we have Kf. Okay, now in this case we have to use this I value. What is the value of I here? What is the value of I here? So this is called Ventov factor. We have seen this. So its formula is this. First we have calculated molality, number of moles, then we have calculated molality, then we have considered this thing, and we calculated alpha here. Therefore total number of moles at equilibrium is this, that is 1 minus alpha plus 1, that would give us 1 plus alpha. So this is the value of I, that is 1 plus alpha by 1, that is 1.0665. So 1 by got I, we got Kf and M, we can calculate the depression in freezing point. Next question. Next question says that 19.5 CH2F COOH is dissolved in 500 grams of water. The depression in the freezing point is 1 degree Celsius. Calculate the Ventov factor. So let us assume that Ventov factor is I, and Kf, we have seen Kf previously. We will put that value of Kf, right? We can calculate M from here. So 19.5 by molar mass of this compound, suppose it is A, divided by 500 into 10 to the power minus 3, which is the mass of water in kgs, and this value is given as 1.0 degree Celsius. We will put all this value. We know the Kf value from previous question, and hence we will calculate I. So same thing is been done. So 1.86 is known, del Tf is given. We will use this formula to get our final answer, that is 1.0735. Now if you want, you can calculate the value of alpha also from here. Next question. Vapor pressure of 293 Kelvin is this much. Water is this much. Okay. Calculate the vapor pressure as 293 Kelvin when 25 gram of glucose is added. So for that, what we will do, we know P01, it is given, mass of water is given. Now we know that molar mass of glucose we have calculated from here, that is 180 gram per mole. Okay. Now M1 we know, therefore number of moles we can calculate, and number of moles of water can also calculate. We'll use this formula and we will get our P1. Henry law constant for the molarity of methane is this much. Calculate the solubility. You have to calculate the solubility under 760 mmHg. So pressure is given and KH is given according to Henry law, that is P is equals to KHX. So that would give us the value. With this, I end my lecture. We will see the rest of the exercise in the next class. Thank you.